Okay, so the heading for this is diffraction. Okay, we looked at the water tank. I'll move this water tank out of the way. We looked at the water tank, and we also looked at the window to see how waves diffract round objects or bend round objects. So diffraction is just a fancy way of saying bending round objects, waves bending round objects. Waves can bend round objects. Just put water everywhere. Well done. Okay, so all waves can bend round objects. The frequency of the wave changes how much it can bend. So, two examples. We'll do a high frequency example and we'll do a low frequency example. And then I'll give you an example that you might get in a question. Okay? So, all waves can bend round objects. The frequency of the wave changes how much it can bend. So, two different examples. Let's do a high frequency example first. So, we're going to draw a rectangle to simulate a tank. We've got two rectangles. Because we're going to do two different examples, high frequency and low frequency. There are rulers and the trays in front of you. I'm going to stick our object in. Now I'm just going to put an object in that's basically just one single plate, not an L-shaped plate. So one single plate in like that. And this one is going to be a high frequency. This one's going to be low frequency. So high frequency means that the waves will come in with little space between them. High frequency. So the waves are going to come in tightly packed together. Like this. And we're going to see what happens there. Low frequency, they're going to come further apart. And we'll see what happens there. Okay, so copy that down and then we'll talk about what happens in the second part of the diagram. Right, on our high frequency example, we found that the waves bend round the object a certain amount. So draw the same wave and do a little bend at the end. So that's a little bend. So the high frequency example bent round the object a certain amount. Then we found that a low frequency example bent a lot further. So the low frequency example bend a lot more. So what we have is, here is the line in which it would bend down to, and here is the line, oops, it's a bit far round, isn't it? Is that the same height? Is that what's wrong? Not really. Let's change this height a wee bit. A wee bit higher. So the lower frequency would bend round a lot more than high frequency. Okay? So, in terms of putting it into an example that we get in the exam. So we need to know what an object would be. So an object could be a building or a hill. So we take the example of, this is quite a common one. You've got the ground there, you've got a big hill in the middle. You've got a radio transmitter at one end, so this is your transmitter. Yep. And here is a little house at the other side of the hill. Okay, transmitter at one side, house at the other side of the hill. It's the hill in the middle. In case you don't know what it is. And that's the house. TV waves and radio waves. Radio waves have a longer wavelength than the TV waves. So did I say that? Did I say it twice? TV waves have a higher frequency than the radio waves. Higher frequency. Higher frequency means shorter wavelength. So, So let's draw on the waves that we get. So transmitter's transmitting waves all around. So let's say it's transmitting a wave, it hits the hill, and some of it, that says it's TV waves, they will bend down. So this is TV. TV waves do not hit the house. Weedy waves have a longer wavelength, therefore they'll bend more, and they will hit the house. So that's radio. So what we're going to say is, weedy waves have a longer wavelength, shorter frequency, so bend more round the hole, round the hill. Sorry? You can do a dotted line as opposed to a straight line. So weedy waves have a longer wavelength and a lower frequency than TV waves. Weedy waves will reach the house better than TV.